Yeah. So now let's take you can take them either ways, okay? We label them as x1, y1, and x2, y2. M equals x y2 minus y1 upon x2 minus x1. So you can take either of these points. This is how you find the gradient. The gradient is needed to fill this y equals mx plus c. Okay. So the m, the gradient, would be y2 x2, which here is 4 and 6 minus 3 is 3 and 2. M equals 4 minus 3, 1 upon 6 minus 2, 4. Here we can see that the positive gradient gives a line like this. Okay, so we should have known that from the start this is a positive gradient because it's going like this instead of going like that. If it was going like that, that means it would be the negative gradient. Now, to find the equation of this line, okay, we can use either of these formulas. I'm going to show both of them, okay? So, y equals mx plus c and y minus y1 equals mx minus x1. So, here we take these two values, okay? So, there's 2 and 3. We take y equals, we take the y value, you have to take it as, suppose, 3 here in this case, while the gradient here we found out was 1 by 4. The x value we take it as 2. I would like to add brackets just for safety, and plus c. C is the constant we have to find. 3 equals 1 by 2 plus c. We have to find c. C equals 3 minus half, which is 5 by 2. We found the equation of the line equals y equals 1 by 4x, because the m is 1 by 4, plus 5 by 2. If this was negative, suppose the sign over here would also be negative. Here, let's use this part. Y minus y1 over here, suppose the y value is here, 1 and 2, 1 and 1. Let's figure it out. So, y value is 4 equals gradient is 1 by 4, x minus x1. X is here. X, we have to keep that a constant, and x is 6. We get y minus 4 equals 1 by 4 x. Wait, no, sorry. We take 4 to the other side to multiply this because the whole thing is divided. So you can take the 4 here. You get 4y minus 16 equals x minus 6. You take 4y equals x minus 6 plus 16, that gives you plus 10. So 4y equals x minus plus 10. Suppose they've given, write it as y equals mx plus c. We write this as y equals 1 by 4 x plus 10 by 4, which is also 5 by 2. Which is the same as this. Therefore, this proves the point of these two being same, right? The answers are the same. Okay. Now, again we'll draw the x and y. Okay, x, and this is y. Suppose we have here is -2 and here -4. Here is 2 and 4 and 6. I take the 4 points as -2, 2. Let's suppose the first coordinate, and 2, -2, and 6, -4. So 2 -2 that gives a point here. 6 and -4 gives a point here. We form a segment. This is called a segment when it's between 2 points. The line would be going to positive to negative infinity, as I said. So we take this as this is number 2. Now, what we can do is find what the middle of all of this is. This segment's middle. If it was too big, like positive to negative, we could not. So, here is the middle. But it might not be 4, -4 because you have not drawn the sketch, or not might be accurate. So how we find it is using the formula midpoint equals x2 plus x1 divided by 2 and y2 plus y1 divided by 2. So it's basically adding these two, dividing it by 2 and finding the average. Normally, what we do is finding the average for when you want to find something in the middle. Suppose someone's gotten 2 marks while someone's gotten 6 marks. Okay. Now, we can take either of them, but I've already labeled them as 2 and 1. So, x2, this is x2, this is x1, this is y2, y1, y2. x2 is 6 plus 2 divided by 2, comma, y2, which is -4 plus -2 divided by 2. Okay. Now, we get the values as 6 plus 2, 8 divided by 2, 4, comma, -4 and you're adding -2, that's -6, -6 divided by 2, -3. So this is the midpoint we found here using this formula. Okay, so this means the middle of the in between these two lines is going to be 4, -3. -3 is somewhere here, 4 is here. You can see it's not very accurate, of course, but it comes nearby to something like that. Yeah. So now there can be these two terms, okay? Perpendicular and perpendicular bisector. Okay. So what do these two things mean actually? Perpendicular is, suppose you have this line, okay? It doesn't even need to terminate. It could just go on till infinity. Okay? Here we find something, another line that crosses it. But it crosses it in a way that here it forms a 90 degrees, here, and here. So you get 90 degrees everywhere where the line is going with. Okay? It could even be here. here. There can be millions, trillions, and infinite on a line. Now, what's a perpendicular bisector? For the perpendicular bisector, you need a segment which is 2 points and a line in between those 2 points. It can't be just infinite lines. Because now the word bisector tells us we're cutting it in half. Okay? So we find the midpoint, which is this formula. And suppose this is the midpoint. We draw another line or assume another line which is again 90 degrees on all sides, which is a perpendicular but at the middle. So there can be only one perpendicular bisector here. The thing of the gradient, the similarity between the perpendicular and the normal line is the gradient of the normal line into the gradient of the perpendicular. Let's just show it like that, but inside let's show it like this, equals -1. So when you want to find this you want to find the perpendicular bisector's gradient, you get the negative reciprocal of the gradient, right? And for the normal one, also negative reciprocal of the gradient, perpendicular bisector's gradient. This is what connects the perpendicular to the line, right? Now there's another term, I'll go on this again, but there's another term called parallel. What does parallel mean? This means there are two lines, but the thing between these two lines is that gradient equals the same. The line of this is line 1, this is line 2, the gradients are the same. That means the perpendicular. That means they will, no matter what they do, they will never meet at a point. Never. Because they're both increasing at a steady flow. And if they're going like this and they're not going like this, even if there was a slight curve, even if this was 1 and this was 0.9, they would not be perpendicular they would not be parallel, sorry. Now, let's get back to the perpendicular bisector. Here, we found the midpoint as 4, -3. Now, we draw a perpendicular bisector. Okay. Now, we don't know where this perpendicular bisector is cutting. So we find the gradient of these 2 points. This line. M equals y2 minus y1 upon x2 minus x1. The gradient equals let's take this as y2 and x2. So -4 upon 6 minus 2 minus 2. Okay. And the gradient. This is going to be a negative gradient. I'm already seeing, because it's going like this, not like this. The gradient will be -4 -2. Okay, that's a little confusing. So okay. Sorry. So -4 so you get -2 as up for the x, the y thing over here on the numerator. The denominator is 6 minus 2, which is 4. Right? As I said, it will be negative. So the gradient of this is -2, 4, which can be written as 1, 2. 1 upon 2, sorry, my bad. To find the gradient of the perpendicular bisector, actually just the perpendicular or even the perpendicular bisector, as I said, negative inverse. So you multiply this by -1, you get 1 by 2. You reciprocal it, you get 2 by 1, which is 2. Right? So we got that. For this is what happens when you have a perpendicular bisector here. You need to find the equation of that. So you take y minus y1. You have to take it the midpoint. The midpoint here is 4 comma minus 3 minus 3 equals m, which is 2, because we're finding the of this 2 into x minus 4, right? Yeah. We find y plus 3 equals 2x minus 8. You take y equals 2x minus 8 minus 3 minus 11, right? Okay. So this we found is y equals 2x minus 11. Now, I'm going to show you one more thing. You're going to find the x-intercept, where that point is, where it's intersecting the x-axis. So, what you have to do is take the y value as 0. Because you don't know what x is, but you know at this point, on this line, anywhere on the x-axis, y is going to be 0. Here is 0, 0. This is going to be 0 in the y value, and this is going to be 0 in the x value. So, to find the intercept, what we can do is take y equals 0. 0 equals 2x minus 11. Right? So, since you take the 11 there, equals 2x, x equals 2 by 11. Right? Yeah. So, the x-intercept will be at 11 by 2. My bad, sorry. 11 by 2. And the y-intercept, over here, the y-intercept, you take x as 0, because everything on the y-axis will be, x will be 0. So y equals 2, 0, minus 11. We all know 2 into 0 is 0. So y's intercept is at minus 11. So where this line is 11 by 2. If you want to write that as fraction, that's going to be 5.5. This is going to go, and this point will be minus 11. So that's clear. Now